So this is for exam 2. This is lesson 2 in our series of videos where we're going to look at dealing with fraction notation and multiplying fractions and just understanding the fundamentals of what is a fraction. So we'll start with identifying the numerator and denominator and how we can write part of a set or a part to part, part to whole in regard to ratios. Then we'll look at multiplying an integer by a fraction and then a fraction by a fraction. So in the beginning here, we're seeing that when you have the number 2/3, that thirds just mean how you are dividing the whole. Okay, so the whole is a big deal. And so when we have one whole, we're dividing it into 3 parts. We're counting 2 of them. When you're counting, you're numerating, you're adding those pieces together, you're counting. So that's why we call it numerate and denominate. To denominate means to divide, and to numerate means to count how many pieces that you're talking about. In this case, we were talking about 2 of the 3. So let's determine the whole. So I'm looking at this and I'm saying 1, 2, 3, 4, 5, 6, 7. There's 8 pieces. So the whole is divided into 8 pieces. And if I want the shaded part, so I'm thinking about the yellow, I see that I have 4 of the 8, which is equivalent to 1/2. Count the whole pieces, so 1, 2, 3, 4 that are shaded, 5, 6 total. 4 that are shaded, that would be 2 to 3. This is what we're saying is a part to whole. And so the shaded region, there's 4 of those pieces that we can count. That's where the 4 comes from. And then the 6 is just your total. And 4/6 is the same as 2/3. Now, if we wanted to go purple to white, well, now that's going to be 4 to 2, or it's 2 purple for every 1 white triangle. So that would be the idea of a part to part. The whole in this case is 1, 2, 3, 4, 5, 6, 7, 8. So one entire circle shaded in would be 8/8. Another one would be another 8/8. And then we're still dividing the whole into 8ths, but we count 3 of those shaded pieces. So this 8/8, we can numerate the numerators. So count those denominators. 8 and 8 is 16, 17, 18. We've got 19/8, which is equivalent to, if we make these whole amounts, we get 2 and 3/8. Both of them are equivalent. One is written in a improper form, and so this would be a mixed number. We call it mixed because it has a whole number as well as a fraction, and this would be an improper fraction, where the numerator is larger than the denominator. So when we're thinking about fractions, and when you have numbers like 8 divided by 8 or -3 divided by -3, when the n divided by n is the same, you're going to equal 1 as a whole. So whether that's 14 divided by 14 or -10 divided by -10, it's all going to equal 1. Could be that you have an item that's subdivided into 3 parts and nothing is shaded. So you would ask what's the part to whole of the shaded region. We would say, well, 0 out of 3, or it would be 0 as an answer. And so that's what this algebraic property, just saying that if no matter how many parts that we divide it, which is your n, if we don't have any amount or nothing is there to count, then we would call it 0 out of n, which would be 0, or in this case, there was 3 as a denominator. So 0 divided by 3 would be 3. Well, what happens when you have, when you're dividing by 0, and that would be that I have, it could be that you have three parts out of nothing, and that would end up being an undefined value. What happens if the fraction is, let's give n a value of 5, and 5 divided by 1, notice you're going to get 5, so that's what this is saying. If n is in the denominator, if n is in the numerator and 1 is in the denominator, then you know the answer will be 5. If that's -3 divided by 1, the answer is -3. So if it's -4 and -4 is your n, then you're going to get n or -4 as your answer. So here we're going to determine the whole. And so we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the denominator. The entire whole was divided up into 10 pieces, and we can count 3 that are shaded. So 3 is our part, 10 is our whole. If we wanted to do orange to white, well, that would be 3 orange to 7, and notice that the sum of these numbers, 3 plus 7, is going to be 10, which equals the whole amount. So here we see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We have 10 pieces. The whole is divided into 10 pieces, and 5 of them are shaded. That's the same as 1/2. So if we said, what about orange to white? Well, this would be a 1 to 1. And notice that 1 plus 1 equals 2, and that sum equals the equivalent fraction denominator of 1/2, which is equivalent to 5/10. And that's the way it should be. You should see that your parts add to your whole piece. Here we've got 10 out of 10, so this would be your total, which is your whole, and 10 would be your parts. So 10 divided by 10 is equal to 1. That's your n divided by n. Now if we look at a linear measurement with the ruler, you have to look at what the whole is subdivided into, because remember, each of these represent whole amounts. So I see 1, 2, 3 tick marks in between the 3 and the 4, which means that it's subdivided into fourths. So the red line goes past 1 hole, 2 holes, past 3 holes. So we're dealing with 4/4 plus 4/4 plus 4/4. And then it stops right here, which would be 1/4. So this is 1 plus 1 plus 1 plus a fourth. So that would be 3. So our answer would be 3 and 1/4. Or we could say 12 and 13/4, because we can count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So 13/4 and 3 and 1/4 would be equivalent. Again, we have not changed the value of the whole, so it would be fourths. And notice it doesn't quite, from 4 to 5, it doesn't quite get to 5, but we see we've covered 1, 2, 3/4. And notice that the whole number that we passed was 4, so we could say 4 and 3/4. Wasn't quite 5. The red line didn't quite get to 5, so we know it was beyond 4, and so 4 and 3/4. So the next part, we're going to look at multiplying and dividing fractions. So when multiplying fractions, what you're thinking about is when you have something like this, and I'm just going to continue to discuss the visual here. If I want 3 groups of 1/4, so that's 1/4 plus 1/4 plus 1/4, which would be 3/4. So when you're taking 3 and multiplying it by a fourth, you get 3/4. The common error is for students to multiply the 3 by 1 and the 3 by 4. And notice that would give you 3/12 or 1/4. And that is a big difference here, which is incorrect. So when multiplying, you got to think of what's going on. That's what I like to talk about groups of. So if I have 5 times 2/5, that just means I've got 5 groups of 2/5. And when you add all those together, this is repeated addition. That's why we like to do multiplication. But this would be 2, 4, 6, 8. This would be 10/5, or equal to 2 to 1, or just 2. Now, how would we get 2 out of this? Well, it would be 5 times 2 is 10. We would have to leave the 5 alone in the denominator to get 10. Otherwise, incorrectly, we would say if we did 5 times 2 and 5 times 5, that's 10/25, or 2/5, and that's nowhere the same as what our answer would be. So the answer would be 2. So again, you're multiplying the whole number by the numerator only, and then dividing it all by your denominator. So it'd be 10 divided by 5, which is 2. So let's look at an example in context. A real estate developer owns a plot of land, and 2/5 of the plot of land will be for a strip mall, and then 2/3 of that would be for a parking lot. So if we think about how we can look at the area here in a model, 2/5 of that land So I want to deal with 2/5. So this is going to represent two-fifths, and over here is actually 1. 1 times 2/5, and so this in yellow represents 2/5. Now what I want to do is I want to then that region right there, if the rectangle is the whole, then what's in yellow is for the strip mall. Now of that, I want to create it thirds. And I want 2/3 of that. So 2/3. Okay, so let's think. Now it's not a whole number now. It's split into thirds, and I want 2/3 of what's in yellow. So if you'll notice that each row that was created is representing a third. So I actually want 2 of those thirds. Now, we're only counting what's in green. Which part of the lot will be used for parking? So what's in green is for what is the total. The total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 4/15 would be for parking. Now think about how you could get 4/15 if you're multiplying the fractions. So 2/5 times 2/3, you can multiply 5 by 3 because we've created a rectangle. Remember, we created a rectangle of 15, and then we wanted 4 of those pieces, so 2 times 2 would give us 4. So we're really multiplying those numerators and those denominators. And then here's another look at when you're creating the model. So we took the rectangle right here, and we created 2/5, and then of that we created 2/3. So really that's what you're seeing, is this is now being overlaid on top of this, and that's what you see over here. So this is the region that would represent the parking lot. A recipe calls, another question here with context, a recipe calls for tossed salad, 3/4 of a cup of almonds. How much is needed to make a half of the recipe? Well, you're multiplying by half. So 3 times 1 is 3, 4 times 2 is 8. If we looked at the area model and create a whole that has to deal with fourths, and I want 3/4, so here you're dealing with fourths, and you created 3/4. So over on the left side, I want to create half. So now we've created half, and I want half of what was in yellow. Well, now we're only looking at what's in green, and that would be 3 out of the 2, 4, 6, 8 total. So yes, we can draw the area model, but we can also multiply the numerators and multiply the denominators. So if we have 3 multiplied by 1/8, that's 3 groups of 1/8, so that'd be 1/8, 2/8, 3/8. Or I could multiply the 3 by 1 and get 3 with the denominator of 8. If I want 2 multiplied by 1/5, that would be 2 groups of 1/5, so that'd be 1/5 and 2/5. Or I can multiply the 2 by 1 to get 2 divided by 5, so 2/5. Here, this has a negative. That's okay, because what's a negative times a positive? We know the answer is going to be negative. And we would have -5 multiplied by 1/6. And we could flip this around if we wanted to. We could say 5 times -1/6 if we wanted to think about, well, there's 5 groups of -1/6, so we know the answer would be negative. And 5 times 1 is 5, denominator of 6. So as you see, this 5 is not being multiplied by that 6. It's not happening. This 2 was not being multiplied by that 5, and that 3 was not multiplied by that 8. Same thing on D. 7 will not be multiplied by 5. You'll have 2/5 times 7. So if I had 7 groups of 2/5, that would be 14/5. These two are being multiplied. Denominator stays the same. So now if we look at 2/5 times 2/3, remember, you can multiply the numerators and multiply the denominators. So you're going to get 4/15 for A. For B, if we say 3/4 times 3/5, we would say 3 times 3 is 9, 4 times 5 is 20. So think about it, when you have 3/4 and you're going to take 3/5 of it, you've got to find a whole that's much smaller. It creates smaller pieces, but you're going to have 20 pieces. And so 5 times 4 is 20, so that can create your total number of pieces. And then 3 times 3, I should see 9, since I should see 9 pieces of that 20. C is a negative 1/4 times 1/10, and so negative times a positive we know is going to be a negative, so you're allowed to multiply the numerators to get 1. So that would be negative 1, and I can place, notice that I can place the negative here. 4 times 10 is 40. I can place it there. I can place it in the numerator, or I can place it in the denominator. Typically, you're going to see it written like this or like this. And finally, if we take 2/3 and multiply it by 4/5, imagine seeing the whole divided into thirds, and you want 2/3, so you want all of this. But then of the 2/3, you want to find 4/5. So this is representing your 2/3 with this side here, and this side here we're wanting, we want 4/5 now. So that means I've got to change my color and show that, well, the orange represents 2/3. Well, I want 4/5 of those 2/3. So notice that everything, the horizontal or the rows are all representing fifths, because there's 5 rows. Well, I want 4 of them. 1, 2, 3, 4. So now I'm counting what's in green, and that's 4. And the total, remember, we created was a 5 by 3, so we created 15. And so here, if we've got 5 halves multiplied by a half, we would have 5/4. And let's look at another one. So what if I had -3/5 multiplied by -2/6? I can multiply the numerators and get +6. I can multiply the denominators and get +30. But now I want to see if I can always simplify. And 6/30, this is where we're going to talk about soon. We're going to talk about, all right, I want to try to simplify my fractions. So if there's something that's a common denominator or a common factor that I can divide out, and I can with 2, or I can divide out 3, or I could divide out 6. So 6 would be the largest factor of 6. So if you divide 6 by 6, 1, 30 divided by 6 would get 5. You'd get 1/5. Here you would get 2/10, and here you would get 3/15. These are all equivalent, but only one is simplified as far as you can, and that is your 1/5.